Just a reminder, so, ka, toa. S stands for sine, which is opposite and hypotenuse. Sine uses the relationship between the opposite and hypotenuse of a triangle. The cosine uses the adjacent side and hypotenuse, and the tangent uses the opposite and the adjacent. And we can use this to set up equations to be able to solve it. Remember, sine, cosine, and tangent are ratios. They are like our scale factors for how do we find the missing sides, because all angles have a particular relationship in the triangle. So the way that we set this up is in the same order. So it will be O over H, or the opposite side over the hypotenuse side. In the case of this triangle, the side that is opposite of theta is BC, so it would be the sine of theta is equal to the value of BC over the hypotenuse, which is AB. And so that's how you would set up your equation, and you're going to have two of these three pieces of information to solve them. Cosine uses adjacent and hypotenuse, not just adjacent and hypotenuse, but adjacent over hypotenuse. So cosine would be adjacent divided by hypotenuse. And so we would set up our equation. The cosine of the angle, whatever it is equal to the side that's adjacent to the angle, which in this case is AC, divided by the hypotenuse, which is again AB. And then similarly, tangent is the opposite side over or divided by the adjacent side. So it would be opposite divided by adjacent. In this case, it would be tangent of theta is equal to opposite. Opposite across from theta would be BC over adjacent, which would be the side, but not the hypotenuse, which would be AC. And so those three right there are foundational for how we are going to ultimately set up and solve for missing pieces of our triangle. So let's look at one that has numbers on it. So write the following as ratios. So the sine of A. Sine of A, so here we're looking at angle A. Angle A, so we want to be opposite, adjacent, and the hypotenuse based on relative to A. So opposite of A would be 3, adjacent to A would be 4, and the hypotenuse of that triangle is 5. So sine is opposite over hypotenuse, so we would say opposite 3 over hypotenuse 5. What that means is there is a particular angle that has a relationship, and we are going to be able to ultimately find out what that angle is. The cosine of A is ka, adjacent over hypotenuse. Adjacent is 4 over the hypotenuse, which is 5. And then tangent is toa, O over A, opposite 3 over adjacent, which is 4. Now, C, the only thing that happens with C is now your opposite and adjacent are going to change. So when you're talking about relative to angle C, 4 is opposite and 3 is adjacent, and 5 is still the hypotenuse. The sine of C would be opposite over hypotenuse. So opposite of C is 4, and the hypotenuse of the triangle is 5. The cosine of C would be adjacent over hypotenuse, adjacent to C. Yeah, totally fine. Sorry about that. Cosine of C would be adjacent over hypotenuse. The adjacent side would be 3, and the hypotenuse would be 5. And then the tangent of C would be opposite over adjacent, opposite from C, which would be 4, and adjacent to C, which would be 3. Now, a couple of things to notice. Notice that the sine of A and the cosine of C are the same thing, and the cosine of A and the sine of C are the same thing. Remember, these are complements of each other. They add up to 90 degrees. And then the tangents, notice that they are reciprocals of each other. That will always happen. So I wanted to show you some of the questions that show up on the SAT relative to sine, cosine, and tangent, some of them. One of them would say triangle PQR has right angle Q. If the sine of R is 12 over 13, what is the value of the tangent of P? So this is how you would work this problem. First thing, we don't have triangle PQR, so we need to create one. And you need to read because it tells you how to set it up. It says right angle Q. because that matters. So we have Q there. Now from there, it doesn't matter where we put P or R. I'm going to put R there and put P here. There's no rhyme or reason because this is going to govern where everything goes. So sine of R is opposite of R and the hypotenuse of the triangle, O over H. So, right? So opposite of R is PQ. So we're going to put our 12 right there. And then the hypotenuse of the whole triangle is PR, which is 13. Now it's asking for the tangent of P. The tangent of P, remember, is O over A, TOA. Okay, so we're going to need opposite of P and adjacent to P. Okay, so you got to pay attention. We were dealing with R, now we're dealing with P. So opposite of P is right here, and it's this missing piece. But remember, this is a right triangle, and so Pythagorean theorem rules still apply, right? Well, if you remember your Pythagorean triples, 5, 12, 13, then that makes this a quick way to find that missing piece. You could also do x squared plus 12 squared is equal to the hypotenuse squared, a squared plus b squared is c squared. So you get x squared is equal to 25, or x is equal to 5. Whichever way, through triples or through Pythagorean theorem, we find that QR is 5. Now we can say the tangent of P is the opposite, so the side that is opposite of angle P, which is 5, over the adjacent side to P, which is 12. And so the tangent of P is 5 over 12. Okay, so that's one way that the question might show up. In the right triangle ABC shown right here, sine of x is 5 over 8. What are the values of the cosine of y, the tangent of y, and the tangent of x? So let's get everything labeled based off what the information that we have. The sine of x. Remember, sine is so, that's opposite over hypotenuse. Opposite of x would be here, so you've got your 5, and then the hypotenuse of the whole triangle is 8. Okay, so what are the values? Well, we probably figure if we're going to have 3 of these that we're probably going to need this adjacent side also, that third side. 5 and 8 do not have a triple value, so we'll need to calculate those. So we'll use a squared plus b squared is equal to c squared. 64 minus 25, you get a squared is 39, which means that a is equal to the square root of 39. So we'll put that right there, and we used Pythagorean theorem to get it. Now we can use our trig values and ratios to find everything else. So the cosine of y. Cosine of y is equal to, remember, cosine is adjacent to y and the hypotenuse of the triangle. So adjacent to y would be 5 over the hypotenuse, which is 8. Okay, notice, just like we said before, the sine of A and the cosine of C are the same. Same thing we've got going on here. The sine of X and the cosine of Y are the same. Let's do the tangent of Y. The tangent of Y, whatever the angle is equal to opposite of Y, which would be the square root of 39, over the adjacent to Y, which would be 5. And then we have the tangent of X. Okay, the tangent of X is equal to the side that is opposite OA, tangent O over A, so opposite of X, which is 5, over adjacent to X, which is the square root of 39. Now, remember, we're not allowed to leave the square root of 39 in the denominator, so we want to rationalize that. We would multiply by the square root of 39 over the square root of 39. So actually, the tangent of X is equal to 5 square root of 39 over 39. I just want you to know how to handle that in case that comes up on the SAT. But these two questions are an SAT question. And what you do is you set it up according to the ratio that they gave you. You find the missing side using Pythagorean theorem, and then you reset it up based off of the ratio that they're asking for. Okay? Now, one thing about trig is it's all based on similar triangles, just like we did in the last unit. So another way that the questions might show up on the SAT is triangle ABC is similar to triangle DEF. where A corresponds to angle D. What is the value of the cosine of F? Notice I don't have any values on my smaller triangle at D, E, or F, or D or F. But what it means corresponds is it means that A matches up, corresponds with D. And we know that if they're similar by if they're similar, then it also means that the angles are congruent to each other. So we automatically know that that means that A is congruent to D. By the third angle theorem, that tells us that C is congruent to F. So we want to find the cosine of F, but I don't have any numbers on that triangle. I do, however, have numbers on this triangle. And since I know that F and C are corresponding and congruent, that means that I can set up the proportion for the cosine of C, and that will give me the cosine of F. So set that up. The cosine of F is equal to the cosine of C. Remember cosine, ca, A over H, adjacent over hypotenuse. So adjacent to C, which would be 24, over the hypotenuse of the triangle, which would be 30. So ultimately then, reduce the cosine of F is equal to 4 over 5. And so what we can do then, used to, we would have to go to a table, and we would pull up our table, we would find 0.2 on the table, and we would go across to the cosine column and find out how big the angle was. But that tells us the angle. This is just the relationship between the sides that are adjacent and hypotenuse and the hypotenuse of the triangle. So this is just the relationship, but we can use it to find the missing side. And in fact, that's how we're ultimately going to use these equations, is we want to be able to find those missing pieces. That's what the most useful is. So we're going to start today. We're not going to solve just yet. We're just going to set up the equation so you can see the pieces, and then we'll start solving later. So here's the setup that you might have. You have to figure out what the sides are, just like we did in the beginning. This is the adjacent side, and this is the hypotenuse. And I recommend you go ahead and label those just so that you don't have to keep it in your head. A and H, that's ca, right? Ca is cosine. Cosine is the adjacent side over the hypotenuse. So we'll do this. The cosine of the angle is equal to the adjacent side over the hypotenuse side. Every equation is going to have that kind of format. The function of the angle equals a side divided by a side. It will always look like that. Okay? So we'll look here. We're going to look at the two sides that I have. X is opposite of 56 and 25 is adjacent. That's O and A. That would be TOA or tangent. So the tangent of the angle is equal to the opposite side divided by the adjacent side. And later on, I'll show you how to set that up. And the reason that we know is that every triangle that has a 56-degree angle, the opposite and the adjacent side have a particular ratio. And in fact, it is 1.4826. So this number right here, that scale factor, is 1.4826. That's the relationship between the two sides. Okay, so that's what we're going to end up doing. Now, let's continue. 50. 12 is opposite of the 50-degree angle, and y is the hypotenuse. O and H, that's sine. The sine of the angle is equal to the opposite side divided by the hypotenuse. Notice that the variable is not always on top. And in fact, if you look at this next one, the variable is not even on top or on bottom. Okay? It is the angle. So here's your angle. 8 is opposite. 17 is adjacent. O and A, that's tangent. So the tangent of the angle, which in this case is x, is equal to opposite 8 over adjacent, which is 17. So the variable can be on top, the variable can be on bottom, or the variable can be the angle. It can be in any one of those three places where we usually put numbers. Okay? Now, one more question this is an SAT question. In right triangle ABC, the length of side AC is 12, the measure of angle A is 40, and angle B is a right angle. Which of the following can be determined using the information given? Well, we don't have a triangle and we need to be able to see one, so let's draw it out so that this makes more sense. It says the length of AC is 12, but the problem is I don't know what goes here yet. Angle A is 40 and angle B is the right angle. Okay, so we can put our B there. It doesn't matter where we put A from there. I'm just going to put it right there. And then AC, which that means there's C. So AC is the hypotenuse. It is 12. So now we have an accurate triangle that we can look at based on what the information that was given. So which of the following can be determined using the information given? Can we find the measure of angle C? If this angle is 90 and this angle is 40, can I find that angle? Yes, the sum of the interior angles of a triangle add up to 180. And these two angles of a right triangle are complementary, which means that angle is 50 degrees. So yes, I can find the measure of angle C. Then the question says, can I find the length of side AB? Okay, well, side AB. Here's side AB. Can I find that side? Now I can. Now that I know how to use trig, I can. That side is adjacent, and that is the hypotenuse. So I could use the cosine function to be able to find the length of side AB. So I can use 1, I can do 1, and I can do 2. So my answer would have been C, which summarizes what we're doing to set it up. We can find missing angles, we can find missing sides using sine, cosine, and tangent. And so our next lesson will be how to, now that we know how to set up the equations, how can we solve them?